hiding in the dark corners of the universe, the 95% we still don't understand. 95% of the universe is invisible, and we still don't know what it is. Welcome to the dark side of the cosmos, where dark matter, dark energy, and unknown forces shape everything we see, yet remain undetectable. In this 40-minute cinematic deep dive, we explore the most mysterious and scientifically baffling aspects of the universe, from the invisible scaffolding that holds galaxies together to the silent force that is accelerating the expansion of the cosmos faster than light. We'll uncover what dark matter really is, how dark energy could destroy the universe, strange gravitational wave signals we don't understand, theories of cosmic voids, multiverse collisions, and quantum space fabric. The real scientific instruments searching for the unseen. From labs buried under Earth to telescopes that see back in time, scientists across the USA, UK, Germany, and Australia are uniting in the most important hunt of our time, to uncover what's hiding in the dark corners of the universe. Subscribe to Future Way for the most intelligent, viral, and curiosity-fueled content on space, AI, and scientific mysteries. Like if this blew your mind. Comment what part of the universe you want to learn more about. Share with anyone fascinated by the biggest mystery of all, existence itself.
257. 257. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. 2, 5, 7. 2, 5, 7. 2, 5.
Hiding in the dark corners of the universe. The 95% we still don't understand. We've mapped continents. We've explored the ocean depths. We've even walked on the moon. But what if I told you that everything we've ever seen, touched, or understood, from planets, stars, and galaxies to your own body, makes up less than 5% of the universe? The rest, a staggering 95%, is invisible, undetectable by traditional means, and still not fully understood by science. Welcome to the dark corners of the universe, the realm of dark matter, dark energy, and cosmic phenomena so mysterious, even our best physicists struggle to explain them. Today on Future Way, we're going to explore that unknown and what humanity is beginning to uncover within it. Let's start with the basics. Everything you see in the night sky, stars, planets, nebulae, entire galaxies, all of it, all the light and structure we understand accounts for just 4.9% of the total mass energy of the universe. That's it. The rest? It's made up of 26.8% dark matter and 68.3% dark energy. Invisible substances that don't emit or reflect light, can't be seen, and yet govern the structure and fate of the cosmos. It's like trying to understand a book with only one word on each page. The universe, it turns out, is hiding most of its story in the dark. So what exactly is dark matter? We know it's not made of atoms. We know it doesn't interact with electromagnetic force, meaning it doesn't absorb, reflect, or emit light. But we also know it exists because of its gravitational effect. Without dark matter, galaxies would spin apart, their stars flung into space. But they don't. They hold together tightly, as if an invisible scaffold is keeping them intact. That scaffold is dark matter. It creates gravitational glue. It forms halos around galaxies. And although we can't see it, we've mapped it indirectly, like detectives tracing footsteps in snow we cannot touch. Now imagine this. Scientists believe there may be 10 times more dark matter than ordinary matter in the universe. It's everywhere, including right here. Billions of dark matter particles could be passing through your body every second, and you wouldn't feel a thing. In fact, vast underground laboratories in Italy, South Dakota, and under Japanese mountains are built just to try and catch a single interaction, a single whisper from this silent material. But if dark matter is the scaffolding, dark energy is the engine. In 1998, two independent teams of astronomers made a shocking discovery. They found that the universe isn't just expanding, it's expanding faster over time. That doesn't make sense, right? Gravity should be slowing everything down, but it isn't. Something is pushing space apart, stretching the cosmos like a balloon with a hidden hand. That hidden hand is dark energy. It's everywhere, evenly spread, and totally unlike any other force we know. We don't know how it works. We don't know what it is. But it makes up nearly 70% of all energy in the universe. Now here's where it gets wild. Dark energy could eventually rip the universe apart. If it continues accelerating the expansion, stars will drift away from galaxies. Galaxies will drift beyond each other's light horizon. And ultimately, even atoms could be pulled apart in the far future in what physicists call the Big Rip. Other scientists believe the acceleration might slow, and the universe could collapse in a big crunch. Or maybe it will coast forever, fading into an eternal cold, dark void. And then, in the background of everything, there's the cosmic microwave background, CMB, a faint glow left over from the Big Bang. When we look at the CMB, we're literally seeing the oldest light in the universe, stretched by billions of years of expansion. But even the CMB has anomalies, like the cold spot, a vast region of space that's cooler than it should be. Some theories suggest it's the imprint of a collision with another universe, or perhaps the result of a massive cosmic void we can't yet explain. Now let's go deeper. Scientists have begun detecting mysterious gravitational waves, ripples in the fabric of space-time caused by massive cosmic events like black hole mergers. But what if some of these waves are coming from unknown forces? What if we're hearing echoes of objects that don't emit light, like primordial black holes from the early universe, or even hypothetical boson stars, strange configurations of exotic particles? And speaking of strange, some physicists now suggest that dark matter might be an entirely different kind of particle. Not WIMPs, weakly interacting massive particles, as originally hoped, but maybe axions, or sterile neutrinos, or even something we haven't yet imagined. There's a possibility dark matter has multiple forms, including ones that behave like waves or form invisible dark galaxies, clumps of matter we can't see but that orbit within our own galactic neighborhood. But maybe the biggest mystery isn't dark matter or dark energy. Maybe it's the question that haunts every scientist who studies space. Why is there something instead of nothing? Why does the universe even exist? Could the dark corners of the universe hold the answers to our own origin? What if the structure of space itself is quantized, like a fabric made of Planck-scale threads, and dark energy is simply the tension of that fabric? What if black holes don't just devour, but actually leak information, holding gateways to other realities, or links to the multiverse? This isn't just speculation. These are real questions driving billions of dollars in research. From CERN's particle accelerators to the James Webb Space Telescope to gravitational wave observatories around the globe. Each new observation adds a piece to a puzzle so vast, we may never see its edge. But there's hope. With next-generation observatories like the Nancy Grace Roman Telescope, Euclid Space Telescope, and dark matter detectors like Lux Zeppelin and Xenon T, we're coming closer to the truth. Every whisper of a particle, every tiny ripple of space-time, and every shadow of missing mass brings us closer to understanding what's hiding in the dark. And a conclusion, call to action. So the next time you look up at the stars, remember this. What you're seeing is only a sliver of what's really out there. The universe is hiding secrets in plain sight, and we've only just begun to ask the right questions. If this journey into the cosmic unknown lit up your imagination, hit that like button, subscribe to Future Way, and share this video with someone who still believes we've figured it all out. Because in the dark, that's where the truth often hides, waiting for someone curious enough to look deeper.